Hello, everyone, and welcome to our December online viewing session. It is great to see you all here tonight. I hope everyone can hear me okay. Give me a thumbs up if you can. Fantastic. It's great. Again, it's great to see you all here. Before we begin, let's just lay a few Zoom ground rules. I'm sure you've heard this a little bit already. The thing to keep in mind is if you're watching with somebody, you have somebody in the room with you, just remember, if you're not muted, we can hear every single bit of your conversation, at basically full volume. So if you are going to speak often with the person in the room with you, it's probably best to mute your computer. But I would like it if everyone could be unmuted. So, of course, when the images start to pop up, I can hear oohs and ahs and stuff like that. And at any time, you're welcome to ask questions. You can ask questions in the chat as well. We'll have a member watch questions in the chat. I'll check it from time to time as well. So we'll hopefully have a great evening here. And one thing I would like everyone to do at some point during the night, you can do it now just to get out of the way, is in the chat. You don't have to put your name because we have that already when you enter it into the chat, but just kind of mention where you're from. Of course, many of you are members of the Kalamazoo Astronomical Society. You can mention that. It's good to know how many members we actually have show up, but we're looking to see if we have people from, of course, other states. I'm sure we do. And we're looking to see if we have some more Canadians here with us tonight, and maybe even some people from overseas. I know, for example, in the United Kingdom, it's probably getting fairly late there, but hey, we're astronomers. We like being up all night long. It's what we do. Okay, so let's go ahead and begin here. I'll switch to the old PowerPoint screen and give you just a quick intro of what we're going to be up to tonight. So here we go. So again, welcome to the online viewing session for December 5th, 2020. And just a quick introduction. My name is Richard Bell. I am the president of the Kalamazoo Astronomical Society, which is a pretty decent sized organization in Southwest Michigan. We currently have 180 memberships, which is an all-time high for us. And that translates to roughly probably 260 people when you count family memberships as two. So even though Kalamazoo is not the biggest city in Michigan, we do most likely have the largest club in the state. That goes for any clubs around Detroit or Grand Rapids. So we're very proud of that. There we go. So this is where our telescope currently is, which I'll show you shortly in live video. So the telescope is located in Piishi Observatory, seen here on a relatively clear day, a few clouds here and there. But the name Piishi is Apache for Nighthawk. So the owner of the observatory is KAS member Mike Patton, and he wanted to keep sort of our bird theme for observatories. Even though it's his observatory, he wanted to keep the bird theme because we do have an observatory here in Kalamazoo that's called Owl Observatory. So he kind of wanted something in the bird theme. So, and also something with a Native American flair for the area that it's in. So Piishi Observatory was a very good name. And we're mostly sure we're saying Piishi correctly, but one day we hope to speak with an Apache to confirm that. So it's a 20 by 20 Roloff roof observatory. I'm sure many of you are familiar with Roloff roof observatories. Not the fancy dome stuff, but good old Roloff roof. And there's a total of 4 telescopes in there, including ours. So on the back of the observatory here, you can see a little rectangular shaped box. And this is our S-Bag all-sky 340C all-sky camera. So this is the camera that allows us to check the weather and also view the constellations and maybe even catch a meteor or two. So let me switch to my web browser now, and we'll check out the real sky right now. So we'll look at this screen here later, but let me switch back here. So you can go to our website and go to the Remote Telescope menu selection here. And on your computer, you can select the PEC all-sky camera, and it'll show you this page right here. So from time to time, I'll try to hop back on this page to see what's going on over the entire sky, but you're welcome to watch the all-sky camera as well from time to time on your own, including on nights we don't have a session as well. And it does look like we have one possible meteor right there right now. So that's one thing I was going to mention, is that one time during the night, if you're watching the all-sky camera and you see a meteor, or especially a nice bright fireball or even a bolide, let me know and we'll switch back to the all-sky camera and everyone can check it out. So just a few things to point out here real quick. This little funny structure here is for birds. This we found does keep birds off the dome of the all-sky camera and having messes on there to clean up. So that's what that is. It's basically for birds. We probably won't see any at night, but we have seen several during the day, so that's fun. And this little funny structure here off to the right, which is actually the western sky, that's actually the roof of the observatory. And we do have a few neighbors' lights. This is a red light to a neighbor here. There is a little bit of sky glow visible from Arizona Sky Village, which is where the observatory is located in southeastern Arizona. But it is a very dark site. On the Bortle scale, it's probably about 1.5 or 2 or so. So it's not quite fully dark yet. We try to start these as close to dark as we can, but not terribly late. But note, next month we'll be starting at 9 o'clock. But already with our 1 minute exposure here, you can see quite a few stars and constellations. So we'll just give you a quick tour here. So just remember, north is at the top, south is at the bottom, east is on the left, and west is on the right. So it's like backwards, just like a star chart is. So over in the western sky, we do have, again, still a bit of dusk going on here. But you can see the 3 bright stars of the summer triangle already. We got Vega, Deneb, and Altair. And of course, each of these 3 bright stars in this prominent asterism belongs to 3 different constellations. There's Lyra the Lyre, which is a harp, which is kind of around here. We have Cygnus the Swan with Deneb denoting the tail. You can see Albireo here, everyone's favorite double star. And you can make out the Northern Cross as well. The chart always tends to start out a little noisy, but it'll get a little clearer as the night goes on here. So we do have the Northern Cross and Cygnus the Swan there. And then we have Altair, the head of Aquila the Eagle. And Altair is getting pretty low, but I think you can make out the back end of the eagle's body right there. It's kind of a triangular shape with a wing there, a wing here, and so on. Tail feathers kind of going down to there. So you can see those constellations there. And of course, almost the summer triangle here is almost pointing at these 2 bright objects here. And of course, the bright one is Jupiter. And the one next to it that looks like a very large moon is Saturn. And as many of you no doubt know, there's the great conjunction of Jupiter and Saturn this month on December 21st. And we're very much looking forward to that, although if Michigan weather holds to type, we're not going to get to see it, at least on December 21st. But a great thing to look out for in the days ahead is exactly what day or night, really, do these 2 get so close together that you can't see them separately on the all-sky camera anymore. So that's one thing you can come back and check out on the website, is when will they appear to merge together and form one kind of ultra bright kind of star in the sky. So that's kind of a fun thing to check out. High in the sky here, practically at the zenith, we have the Great Square of Pegasus. Of course, these 3 stars here belong to Pegasus, and this one belongs to Andromeda. Andromeda arcs off this way, and you can make out the head of Pegasus. And above the Great Square toward the north, we have Cassiopeia, which is, of course, embedded in the Milky Way here. We've already kind of lost the central bulge of the galaxy because, sadly, summer is long gone now. And we're well in the fall. In fact, it's practically over. And pretty soon here, we'll have the winter solstice, which is when Jupiter and Saturn here will be very close together in the sky. And you can already see the Pleiades and the Hyades. So probably toward the end of the night, we'll begin to see Orion rising there. So that's a quick look at the all-sky camera. Again, check back on it from time to time, and we'll see what we can see. Oh, one thing, of course, I forgot to mention because we're too busy worrying about Jupiter and Saturn, is you can see a bit of a shaft of light protruding up here. And that is, of course, the zodiacal light, which is basically sunlight reflecting off dust in the plane of the solar system. Basically, you know, comets shed material, gas, mainly dust, of course, and little micrometeorites hit asteroids all the time. And so sunlight reflects off that as it settles in the plane of the solar system. And it's getting more prominent now because we're getting toward the winter solstice. So you'll get to see the zodiacal light better probably next month, I'm guessing, but we'll find out. Okay, so going back to the PowerPoint here. We're going to start with the Takahashi tonight. So those of you that joined us last month knew that we could not use the Takahashi. And it turned out it was a very simple problem. But of course, when the telescope is 1,800 miles away and there's nobody there, even little problems can turn into big problems. So basically what happened is the large black box here is the filter wheel, and the pivot point of the filter wheel came a little bit loose, and so it couldn't change as easily as it should have. And so it just needed a little bit of tightening, and now the filter wheel is good to go. So we are going to start off with the Takahashi tonight. I know a lot of people like to see the stuff from the big scope, but just remember, good things come in small packages. So the Takahashi is one sharp telescope here. So as you can see, the Takahashi rides piggyback on our main instrument, our 20-inch plane wave that we'll talk more about later. And it's basically a very sharp 4-inch refractor. I'll let you kind of read all the details here yourself, but it's again a refractor specifically built for imaging. It is an excellent imaging telescope, as you'll soon see. And of course, you can see we have a flip flat on the Takahashi here, or the Tak as we call it for short. That of course acts as a remote dust cover, but we can take flat fields with this as well. And then we have the instruments on the back here. So the cameras that we use is this one here, a SBIG STX 16803 camera. And we actually have 2 of these. There's one on the Takahashi and there's one on the plane wave. So CCD cameras are still excellent imaging cameras. They're starting to become a little extinct as CMOS cameras take over, but this is still a very, very good camera. And it is a full frame CCD camera with basically nearly 37 millimeter square chip. So it's basically bigger than the old frames of film. And by today's standards, you know, roughly 17 megapixels doesn't sound very impressive, but for deep sky imaging, it's more than enough. And for the limited internet that we have out there, it's fine because each file is about 32 megabytes, but with larger cameras today, the file sizes for individual images can be over 100 megabytes. And that would make things pretty slow out there. So until we get super high-speed internet out there in Arizona Sky Village, which might not be anytime soon, we're perfectly happy with this camera. And of course, many people would love to have this camera. And we're lucky enough to have not just one of them, but 2 of them. So we're going to start with our first target of the night. There's no time to waste. So now I'm going to switch back to the web browser here again, go back to my other tab. And here you can see the web interface for the Astronomer's Control Panel, or ACP. So if you're a KAS member that lives in the area, I'll talk more about that later, and you want to use the remote telescope, this is the screen that you'll see the most. So you don't need any fancy software. You don't need to buy ACP. All you need is a computer, or even like a tablet computer, a web browser, and internet access. Doesn't even have to be terribly high speed. DSL, for example, will do just fine. So we're basically on my web browser here using the ACP interface, and this is where we control the telescope from. You can see the image I took last night. You probably looked at that already, but don't look at that. You'll see it later, don't worry. So I already have the image loaded and ready to go. So of course, our first target is something called M31. Who knows what that is? And I'm just gonna go ahead and hit acquire image, and off it goes. So you can see it'll start the work here and do its thing, but I'll talk more about that later. So yes, indeed, our very first target of the night is M31 the Andromeda Galaxy. Some people were evidently wondering why we didn't do this last month. It's because the Andromeda Galaxy is pretty good size. It's over 3 degrees in length. You know, that's like 6 full moons. So this is the object we'd like to do with the Takahashi. The plane wave just shows like the very center of the galaxy. So this object is much more suited to the Takahashi than it is the plane wave. That is, if you want to see the whole galaxy at once. So yes, this is the object to use with the Takahashi. So of course, as the name suggests, M31, the Andromeda Galaxy, is in Andromeda. It is, of course, visible to the unaided eye. It's often considered the most distant object you can see with your eyes alone. It's not true, but on average it is. We'll actually see another galaxy later that's a little bit more distant that you can see from very dark sites. So the Andromeda Galaxy is truly a deep sky object at about 2.5 million light years away. So of course we see it as it looked 2.5 million years ago. So we can never quite see these things live, even though we sort of say we're doing live viewing. I mean, we're taking a fresh picture, but of course those photons left the galaxy 2.5 million years ago. So M31 was first noted as a small cloud in the Book of Fixed Stars by the Persian astronomer Abd al-Rahman al-Sufi in 964 AD. It's amazing no one noticed it earlier than that. The German astronomer Simon Marius was the first to describe M31 after observing it through a telescope in the year 1612. And Charles Messier included it in his catalog in 1764. You know, that famous catalog that was supposed to be a list of objects that look like comets that you should avoid or not fool you, but turns out to be a great list of objects to look at, of deep sky objects, but Messier didn't quite know that yet. And of course, at 2.5 million light years, the Andromeda Galaxy is the nearest big galaxy to the Milky Way. And I stress big because there are many other galaxies that are closer to the Milky Way. They're just all pretty small compared to the Andromeda Galaxy. So it is very, very large. And of course, we all pretty much know where the Andromeda Galaxy is. So here is a Starry Night version of the Great Square of Pegasus. And of course, this star here, even though the lines of Pegasus connect to it, this star here belongs to Andromeda. So this is Alpheratz, the head of Andromeda. Now, Starry Night shows it as 2 arcs of stars that meet at Alpheratz here. And that's the way I often point it out to people, but you can make it into a stick figure, as we'll see here shortly. So you just kind of follow Alpheratz, go along the top line of stars, go to the first one, go to the second one, just look up there a bit, and you'll see kind of a detached cloud of the Milky Way. But of course, that is a whole other galaxy, the Andromeda Galaxy. So here's a close-up using Sky Telescope's Pocket Sky Atlas. I highly recommend Sky Telescope's Pocket Sky Atlas. They just came out with a new edition. Again, here you can see Alpheratz, and now Andromeda looks like a stick figure, which is a better way to draw it, since it looks more like a person that way, but it's a little harder to see the stick figure than it is those 2 arcs of stars. And of course, the Andromeda Galaxy on this chart here is not hard to find. It's not quite so red and obvious in the night sky, but it's basically just 1 degree above the star here, our second star in the arc here, called New Andromedae. So it's just 1 degree west of that. And so it's very, very easy to find. And of course, as we know, the Andromeda Galaxy is one of the galaxies in the local group of galaxies, basically a collection of, I think, currently 55 known galaxies in kind of a irregular shape, distributed throughout a volume of roughly 1 megaparsecs. That's 1 million parsecs, or about 3.26 million light years. So, of course, that's a tremendously large size for us, but for the universe, you know, that's nothing. So yeah, there are currently 55 known galaxies in the local group of galaxies. It's what we call a poor galaxy cluster, because some galaxy clusters number in the thousands of members. But of the bright galaxies in the local group, 14 are dwarf ellipticals, which is considered the most common type of galaxy in the universe, just because most of the nearby ones to us are dwarf ellipticals. 3 are spiral, but technically 4, but maybe I'll come back to that later. And 4 are kind of a irregular shape. You can't really pin them down to one type. And as you may have also heard, we're due to collide with the Andromeda Galaxy starting about 3.7, 3.8 billion years. So it's not imminent, so don't worry. But perhaps even when they do collide, as we'll see here soon, stars will most likely, in the vast majority of cases anyway, not collide. So as they pass through each other here shortly, stars will not collide and merge, but maybe on a small scale they will. So at first they'll get closer and closer together, pass through each other, and that's when the good stuff happens. As galaxies draw each other in and begin to collide and pass through one another, they basically stir up gas and dust and create a great deal of star formation. So they'll become starburst galaxies for a time. Then eventually, in about 6 billion years, the merger will end and they'll become a super giant elliptical galaxy, much like the ones we find in the famous Virgo cluster of galaxies. But note, in this simulation, there's no merger with M33, because it's been said that the Andromeda Galaxy will swallow up M33 later. But who knows? Maybe it won't. Okay, so let me switch back, see how we're doing here. And we'll see ACP working here diligently for us, all in the background. So we're doing a 300-second exposure, which is 5 minutes to you and me. And we're a good chunk of the way into that now. And you can see ACP does everything for you. So ACP is not, it doesn't control the telescope, but ACP controls the programs that control the telescope, that controls the cameras that take the pictures. So it's kind of a program that controls programs that controls the telescope. And so it does everything for you. You know, it automatically finds a guide star, automatically selects a guide star, guides on that star, and begins taking the picture. But even we can go unguided for about 5 minutes with the Takahashi. So I'm going to go ahead and unmute everyone here, because again, I love to hear those oohs and ahs as the image pops up here, because we're almost there. So of course you might have to unmute yourself as well. You're certainly welcome to do that. And we are almost done. I still don't know why it goes like 2 seconds past. I mean, it's still a 300-second exposure. Okay, now it's done. So what happens now is, of course, the image has to download from the camera. Maxim, the program that controls the camera, will do a quick processing job and then upload the image to the browser here. So we already have the thumbnail image. And in just a second here, we'll have a little pop-up to tell us the image is done. So I can't click on it until I get that little pop-up. There we go, there it is. So now we'll go ahead and click on our first image of the night. It's coming. All right, let's go.
Ooh.
Oh, thank you very much for that. I really appreciate that. So there you go. That is our first image of the night. M31 the Andromeda Galaxy. Now, was that worth the month of waiting? Actually, it was only like 2 weeks or so.
Yes.
Yes. I need it in my backyard.
So let me tell you a little bit about this galaxy here. A little bit more anyway. So, of course, this is the largest, most massive galaxy in the local group. If you just measure the main portion of the galaxy, roughly from here to probably about here, it's about 130,000 light years across. But as you can see, it extends out further, probably even further than we can see here. You know, galaxies don't just suddenly cut off. They gradually fade away into the intergalactic medium there. So if you measure the fainter outer parts of the galaxy, this sucker is 220,000 light years across. So that does make it larger in diameter than the Milky Way, but there are some new estimates that show the Milky Way to actually be larger than we currently think it is. So it might be more competitive to the Andromeda Galaxy than we think, but it's hard because, of course, we're inside the Milky Way. So we do know the Milky Way contains anywhere between 200 and 400 billion stars, but the Andromeda Galaxy is thought to contain upwards of 1 trillion stars. So, of course, at this resolution, we can't really see any stars in the Andromeda Galaxy, but, of course, all this fuzzy glow, these faint fuzzy, as we call them, that's the combined light of hundreds of millions of stars. And so the Andromeda Galaxy, if we could put it on a scale, would weigh about 1.5 trillion solar masses, 1.5 trillion suns, which is heavier than the Milky Way, which is about 850 billion solar masses. And deep inside the central bulge here is thought to be a supermassive black hole about 100 million solar masses, which is considerably more massive than the one in the Milky Way, which is only about 4 million solar masses. So 100 million for the Andromeda Galaxy, 4 million solar masses for the Milky Way. So you can see 2 other galaxies in this picture, at least 2 others. This little nodule here looks like a really bright star. That's actually M32, one of Andromeda's many satellite galaxies. So it's just about 24 arc minutes south of M31's nucleus. And it's about itself about 6,000 light years across and contains upwards of 400 million stars. It's one of the densest known galaxies. And it's very likely M32 was once much larger, but no doubt the Andromeda Galaxy stripped most of its members away. And so only the core galaxies held tightly together by gravity are still around. And this galaxy itself may contain a supermassive black hole of 2.5 million solar masses. And nearby here, we have M110 or NGC 205. And this, again, is another satellite galaxy that contains upwards of 10 billion stars and is about 16,000 light years across. And even though it's a pretty significantly sized galaxy, it is not known to contain a supermassive black hole, at least at current knowledge, as far as I know. There's also a star cloud. I think it's NGC 206, but somebody can correct me on that if I'm wrong, but this is a star cloud within the disk of the Andromeda Galaxy. And of course, you can see the galaxy's dust lanes, much like the Milky Way has. And of course, in the foreground here, just lots and lots and lots and lots of stars in our galaxy. So there we go, our first target of the night. So any quick questions about the Andromeda Galaxy or the image itself before we move on? Again, you're always welcome to ask questions either vocally or in the chat. So I'm going to go ahead and close this. unless you want to stay.
Richard,
yes, go ahead.
The stars around in the background all belong to the Milky Way.
Yeah, so it's actually the foreground. These are all foreground stars. They're actually closer to us than the Andromeda Galaxy. So, yep, pretty much every single one of these, really probably every one of these, belongs to the Milky Way.
Okay.
All right, so thanks for asking that. All right, so we're going to make the Andromeda Galaxy go away here, but let me remind you, at the end of the night, I will give you a link where you can download these images later. But I have to do a little processing on them first. This is processed here, but this is a reduced version of the actual image. So pretty soon here, you'll be able to download it and really zoom in and see the detail. Unfortunately, we can't do that because it would, that would kind of slow things down because, again, the internet there is a bit limited. All right, so that's our first target of the night. And that was only a 5-minute shot. So let's go for something a little more exotic. So we're going to do IC 1396. And all I got to do is hit get coordinates. It's in the catalog here. And I'm going to bump this up. We're going to make this a long one. We're going to go 10 minutes on this one. And now we're going to switch filters to the hydrogen alpha filter. And we'll just hit acquire image. And so let me, I always forget to do this. So let me switch to the other browser here. And I'm just going to hit refresh real quick. Because the video here tends to stall from time to time. So right now it looks like something from the Matrix, but it'll get better. Here we go. So here's a live view of the remote telescope in action. So you can see it begin to slew to its next target and begin the process of centering the image. So first it'll slew to the object, it'll center it precisely, and then it'll look for a guide star, then it'll begin to take the picture. So you can see the flip flat open here on the Takahashi. So of course, this is the telescope that we're currently using. So you can again go to the remote telescope page, select the PEC Observatory webcam, and that's what we're looking at right now. So of course we have our all sky camera that shows us the sky, and we have the observatory webcam that shows us the telescope in action. And so I'll try to go back to this from time to time as well. I don't think the object is that low, so it looks like it's stalled already. So yeah, the video tends to stall from time to time because again, our ultimate nemesis out there is the slow internet connection. There's probably a lot going on there. All right, so let me tell you a little bit about this next object. So again, we're doing IC, or the Index Catalog 1396, the Elephant's Trunk Nebula. And the magnitude is listed as 5.6, but it is a very large object. So that means its surface brightness is low. And IC 1396, I think, is technically the star cluster that's in the nebula, but we'll just call it the Elephant's Trunk Nebula, which is actually a small part of the nebula itself. And as you can see, it's about 2,400 light years away. And every time I show an image like this, the information slide here, as I call it, I always show a sketch of what this might look like through a telescope. And I was looking at the sketch and realized, it looks a lot like an elephant to me. The entire thing looks like an elephant. There's like one big ear here, another ear here, kind of a trunk. There's like an eye here and maybe like an eye over here. So the whole thing looks like an elephant to me, but that's not why we call it the Elephant Trunk Nebula. This is not the elephant trunk that we're referring to. There's even like a tusk right here. So I thought that was really neat, even though that's not the elephant that we're referring to here. So here's what we're going to point at, basically in the basement of the house-shaped constellation Cepheus Taquine, which is right near the brighter, more obvious constellation of Cassiopeia, the Queen. And so IC 1396 is 1.5 degrees southwest of Mu Cephei, which itself is a very famous target. Mu Cephei is known as you can see, Herschel's Garnet star, which I'll mention here shortly. So IC 96 is one of the larger emission nebulae, taking up about 3 degrees of the sky. So because it's large, its surface brightness is low, so it's actually pretty faint.
$10, something like that. Off.
Oh, we're going to have to mute people again. So remember, we can hear every bit of your conversation with somebody in the room with you. So if that's going to happen, be sure you hit mute on your screen. So the elephant's trunk is actually a dense globule cataloged as IC 1396A. But Mu Cephei here, Herschel's Garnet star, is a luminous red supergiant, or possibly even a hypergiant, that appears at the edge of the nebula and is at a distance of 2,840 light years. So it's actually much more distant, or a little more distant than the Elephant's Trunk Nebula here. And it is one of the reddest stars in the sky. And it actually has a very large size. It's one of the largest known stars with a radius of 1,260 to 1,650 times the radius of the sun. So it is most likely a hypergiant at that size. So it's a pretty good size object. So let me again, it's probably going to be a bit here, because with H alpha, you want to do a pretty decent exposure here. And so while we're waiting, let me go ahead and stop sharing here for a minute. And I'll try to peek into the chat here and see if there are any questions we can answer, or see where people are from. So I'm just going to kind of start from the beginning. So we do have people from, one person from Columbia Falls, Montana, Russ Lucas. So welcome, Russ. It is great to see you here. Of course, we have Mike Patton, the owner of PEC Observatory, who is now back in Arizona. When he last joined us, he was still in Plainwell, Michigan, but now he's back out in Arizona. That's how he was able to fix the filter wheel, or at least not fix it, but tighten it down. We do have some Kalamazoo Astronomical Society members here. One gentleman from Glendale, Arizona, another from Morgantown, West Virginia, somebody from Southern California, the Orange County astronomers, welcome. You guys probably have much warmer weather there than we do. So this is why we do the online observing sessions, because for us right now, it's mighty cold outside, but I think it actually is clear tonight. So that's unusual, or maybe partly cloudy now. Got somebody from Milwaukee, Wisconsin. Speaking of which, I just heard that Squiggy died today, you know, Squiggy from Laverne and Shirley. So that's kind of a fun coincidence. Somebody from the Boston area, somebody from Bolo, Illinois, somebody from the Flint River Astronomy Club in Georgia, more KAS members, somebody from the Rose City Astronomers. We'll be joining them in a chat tomorrow. Somebody from Puerto Rico. I believe he joined us at the general meeting yesterday. So he's from the Grand Rapids Club, even though he lives in Puerto Rico now. Somebody from the Mohawk Valley Astronomical Society in Central New York. Annie's back from Utah. So welcome back, Annie. I remember you. Clinton, Ohio. We have someone from New Braunfels, Texas. That's great. We do have someone from the Neville Public Museum Astronomical Society. You guys put that whole name on a t-shirt? That's a pretty long name. From Green Bay, Wisconsin. We do have somebody from Edmonton, Alberta, Canada. I recall chatting with you on Twitter earlier today. Yep, I see a wave in there. You are currently on my screen. So let's see. We do have a question from one of our new members who goes by the nickname Z, which is good for me. How large does the Andromeda Galaxy appear versus the diameter of the moon? I did briefly touch upon that earlier, so I did zip by it pretty quick, but the Andromeda Galaxy on its long axis is about 6 degrees, or I'm sorry, 3 degrees. 3 degrees, at least the bright part. So the full moon is about half a degree. So that is 6 full moons across. So yeah, it's even though it's 2.5 million light years away, it is 6 times the diameter on the long axis as the full moon. And I did see that Kevin did answer that already, so sorry about that. But not everyone's probably checking out the chat. And we do have somebody here from Florida. And somebody's asking if the infrared camera produces noise in the image, especially in H alpha. That, of course, is a very good question. It might to a degree. That's one thing we need to investigate further. And my guess is if we are pointing in the wrong direction in this case, the answer is yes. So that's something we are going to work on. So that's where we're currently at. So if you have not yet done so, at some point tonight in the chat, just sort of mention where you're from if you're joining us a tad late. We're not in class or anything, so I can't scold you for being tardy. I would normally do that. So let's switch back to ACP and see how we're doing. So we're only halfway there. Yeah, so I try not to do too many of these H alpha images, but by golly, are they worth it? So let's pop back to the all sky camera, see how we're doing there. So we can see a little bit of zodiacal light still with Jupiter and Saturn within the zodiacal light there. And looks like we can see a bit of Orion now. You can see Betelgeuse, Bellatrix, the head of Orion. You can just faintly see the belt. Looks like it might be a little dusty, a little murky on the horizon there, which is why we don't look terribly low sometimes. By next month's session, Orion will be quite a bit higher, and we should be able to do the Orion Nebula, which is spectacular with both telescopes. We can just fit the Orion Nebula in with the plane wave, but I don't want to spoil it too much for next month. And let's hop back to the telescope, just get a peek of the telescope there again. So it's a little lower than I thought. I guess that's right, or unless it stalled again. Let me hit reload there, and it should be a little higher than that, I thought. Yep, we're back in the matrix again. Ah, that's much better. Okay. So you can see, yeah, the video does stall from time to time. I'll talk about the mount here later and the main telescope, but again, you can see the Takahashi with the camera and filter wheel on the back. And the exact same camera and filter wheel on the scope here. And you can see our flat field device here. That's the little funny white thing here. Mike Patton's binoculars on a parallelogram mount. This is his 90 millimeter Coronado telescope. And you can't see his other telescopes from this vantage point here. I think this is his MIDI wedge, which I believe he was selling. So I'll do a shameless plug for Mike if you're looking for a good wedge. There's a good one right there for sale. All right, well, I think I'll stop sharing here and just take a good look at everyone. See, of course, not everyone's sharing video. Oh, I should also, of course, give a shout out to those watching on YouTube. So, of course, if we do have people watching on YouTube, welcome as well. Hopefully, we'll try to check the chat there as well if anyone has any questions in the chat on YouTube. And but of course, we are on a 20-second delay on YouTube. So, you know, I briefly mentioned look back time earlier with the Andromeda Galaxy, how we see it as it looked 2.5 million years ago. So those of you on YouTube have hear back time. So you hear my voice as it was 20 seconds ago. So it is, again, great to see you all here tonight. And maybe another thing you can enter into the chat is, of course, if you're not a Kalamazoo Astronomical Society member, how did you find out about the session? So I'm curious to see what publicity methods are paying off for me. And we do have another a couple here from Eureka, California, or Humboldt, Eureka, California. Yes, I do have Grogu here with me tonight. He is my mascot, as always. He's actually a Christmas present for my niece's son, so my great nephew. So he probably won't be here next month, but maybe I'll just have to get my own little mascot on myself. And I can see, of course, Becky has her mascot with her. The big difference between my mascot and yours, Becky, is I don't have to clean up after mine. All right, so it is great to see how people found out about the event as well. So people are sharing that. I'll check back through that later. So let's hop back to the browser and see how we're doing. No more meteors with the all-sky camera. You know, I have yet to see a really, really bright meteor in the all-sky camera. Just kind of faint ones like we saw earlier. Nothing super spectacular yet. Of course, we do not have the all-sky camera or really anything on or plugged in during the monsoon season from July to September. So that's probably when they have all the bright meteors and we don't catch them because everything's turned off, because they do get frequent lightning strikes out there in the monsoon season. And one of our nearby neighbors did have a major blowout from lightning over the summer. So it is wise for us to power down, unplug everything during the monsoon season. And of course, during the summer, it takes forever to get dark out there, and we're usually out observing around here anyway. We, of course, do have an observatory here in town that I mentioned, Owl Observatory, and we just got a new telescope in there that we have yet to share with the public because of, well, you know why. Oh, we're done. Okay, there. Oh, that looks a little murky tonight. Oh, dear. I was hoping for a good one. Maybe it'll look better here. So that's a little fuzzy there. Sometimes it's a bit sharper than others, so tonight a little on the fuzzy side. I might be able to fix that later. So bummer, I was worried about that. So that could be an issue with the infrared stuff we have going on in the observatory. So that is one thing to check out. So here it is. As you can see, it is obviously a target for the Takahashi because it is big. It nearly fills the chip of the Takahashi. So IC 1396 here is more than 100 light years across, which is pretty average for at least large nebulae. It is a bit larger than the more famous Orion Nebula. It's just this is much more distant. And of course, right here is the elephant trunk itself. And so the elephant trunk is about 20 light years from one side to the other. So we're seeing about 20 light years of gas and dust all piled up there, and a bit of a dense knot there. And the star responsible for the nebula glowing here is HD 206267, which I think might be this star here, but don't quote me on that. And this is most likely up here, the Garnet star. But of course, we're imaging in monochrome because that's how you can do the best quality imaging. And of course, the entire elephant trunk nebula itself is a region of star formation, and it contains more than 250 very young stars, less than 100,000 years old. And these weren't discovered until 2003 with the Spitzer Space Telescope. So we have had better images of this, even with the infrared lights that we have in the observatory there. But Mike just installed a new FOSS cam for himself, and that does seem to light up the observatory a bit more. So that's one thing we need to look at there is issues with infrared. So there it is, IC 1396, the Elephant Trunk Nebula. All right, so our next target, we're going to try it and do another H alpha. This one usually turns out a bit better. So we're going to try NGC 1499. Make sure all the digits are there because my keys are getting a little sticky there. Make sure I hit get coordinates. There we we go. And we're going to do H alpha again, obviously, as you'll see why. And we're going to, I did that last month. I didn't hit the button quite right. I'm going to try it again. There we go. That should be good. We'll make sure here it should take off here shortly. There we go. So now it's beginning. So you can see the, I don't know how fast you can read all of this, but it basically just tells you it's getting ready to slew. And now we can see the slew process begin here. So let's switch over to my other browser, because this does not run in Firefox very well at all. Obviously, the streaming video stalled again, as it often does. Some nights are worse than others. Sometimes it can run the whole night without an issue, but there are nights it stalls over and over again. So in the matrix view here, you can see it slewing. There we go. That's much better. And if you are having problems viewing this video on your browser at home, that's because we're viewing an unsecured video. There's Mike Patton with a flashlight for some reason. Maybe he's trying to get the camera to turn off. I don't know what he's doing there. So that gentleman that appears to look like Casper the Ghost, that's Mike Patton, the owner of the observatory, checking things out. So as I was saying, we're using unsecured video over a secure website. So I do have instructions down here how to give your browser permission to view this video, because at first you'll just think it's not loading on your browser. So we're almost there. So let's switch back to the PowerPoint. So our next target is again NGC 1499, the California Nebula. We can say this is in honor of those joining us from California. Of course, I would be lying because I had no idea you're going to be here tonight. So this was discovered by the legendary E.E. Barnard, Edward Emerson Barnard himself, one of the last great visual professional astronomers in the year 1884. And it is a nebula, another emission nebula that is 2.5 degrees long, or about 43 light years, which again, because of its large size, makes its surface brightness very low. And this object is notoriously difficult to observe visually. And so I'm not really certain, but my guess is E.E. Barnard found this on his photographic surveys of the sky. So as many amateurs know, this object is best observed with a hydrogen beta filter at a wavelength of 486 nanometers. There will be a quiz later. In a wide field telescope under, obviously, very dark skies. But of course, most amateurs don't own a hydrogen beta filter. We all have, narrow band filters, broadband filters, O3 filters, but many of us do not own a hydrogen beta filter because normally you read it's good for this object, and I think the nebulosity around the horse head, and that's it. So it's not really a filter with a great deal of applications. So most people tend to look at the $200 price tag, at least for a 2-inch filter, and say, nope, I think I'll invest my money in a broadband or narrowband or O3 filter, which is usually a pretty wide, a very wise decision. So I've never actually tried to view this with a hydrogen beta filter. I have seen them, but I've never tried one. So by coincidence, it does transit the zenith in central California as the latitude matches the declination of the object. It's kind of a fun fact there. So those of you in California, in central California, can test that out. So here's where we can find the California Nebula. Over here, you can see, of course, the Heart and the Soul Nebula. We did the Heart Nebula last year. Maybe we'll do it again next year. I try not to do the same thing every year for a little variety, at least for those of us that join us over and over again. And of course, you can see it's on the border, the edge of Perseus here. In this view, you can actually see it, but of course, with the naked eye, it's just not visible at all. Otherwise, it would have been known for a great amount of time. So a little bit of close up here with Sky and Telescope's Pocket Sky Atlas. And you can see it's just 1 degree north of Xi Persei, or Minkib. So it's actually not very hard to track down with, like a camera and a wide field telescope. But visually, if you have the hydrogen beta filter in dark skies, it's not a difficult object to star hop to. It's just a difficult object to see. Period. So that's where it is. All right. So our logo there means it's time to switch back to the screen, see how we're doing there. There we go. So it does take a bit of time to track down a guide star at times. The guiding does look a little rough tonight. Usually it's a little kind of a wavy curve, but we're getting spikes there. I don't know what the wind is like tonight. So while we're waiting, let me, I have it on my other computer here just to monitor how things are going. But let me fire up AnyDesk on my computer here. And I'll give you a tour of the computer out west. Get it going here. Give me just a second. Being bad. Okay, there we go. All right, so let me share the screen there so you can see what I'm talking about. There's actually 2 of them. I'll try that one. Okay, so hopefully everyone can share, see the screen I'm currently sharing. So this is a kind of truly behind the scenes view of the telescope here. For example, Kevin, if you can't see the AnyDesk screen here, just let me know, but I'm assuming everyone can. So over on the right here, you can see ACP itself. So this is ACP, the program that controls the programs that controls the telescope running right now. So yeah, the little siren there is a good thing. That means it's working. And you can see in the center here, we have Maxim. It's doing the imaging and the guiding. So we do have a guide star there, which is kind of bouncing around. Oh, I see why. And we're still not quite halfway into our 10-minute exposure there. So it does look like the guiding issue is the wind. It's a bit windier than I had expected tonight. It's currently 8.5 miles per hour. We will have an issue if it hits 10. I didn't think the wind would be an issue, so I didn't change the settings on that, just in case. And this thing at the lower left here, this is called M1 Oasis. This is what opens and closes the roof. So the guiding looks okay. It looks like the wind is kind of coming and going. And we're just working away at the exposure there, because you do have to get a decent exposure in H alpha to actually see anything in these objects, at least with the H alpha filter. All right, so we'll hop back to the Zoom here and scroll through the questions. Let's see where I left off at. Okay. Yep, here back time. That's a copyright, by the way. That's you can't use that. So yeah, it looks like a lot of people found out via Twitter. I did tweet at Phil Plate, the bad astronomer, and he often he's come through for us thus far. And somebody found out through the invitation that I sent out to roughly 350 different clubs. Oh, one person did find out from Cloudy Nights. That's great. Again, more people from various clubs around the country. We do got somebody from the San Francisco Bay Area. That's great. And somebody found out through Sky and Telescope. Oh, and someone's asking about the orientation. I hardly ever know, but I think with the Andromeda Galaxy, I'm pretty sure north was at the bottom. And with the Elephant Trunk Nebula, if I had to guess, it was probably also at the bottom. No, it should be the top, but I'm not really sure about that. So off the top of my head, I'm not sure what the orientation is for each object. I would kind of have to check with the star chart later. Oh, and it sounds like somebody found out about the KAS through Frank Severance. So that's great. Thanks for spreading the word there, Frank. We appreciate that. And of course, don't forget, we always have time for questions. So we can try to unmute everyone again, or at least give everyone permission to unmute. And again, if anyone has any questions they'd like to ask verbally, please feel free. Hearing none. Okay. So let's go ahead and switch back to the browser, see how we're doing. There we go. We're getting there. So yeah, boy, look at that. Razor tooth stuff there. So the wind is knocking the scope around a little bit. Usually the Takahashi doesn't mind the wind too much, but ironically enough, when we image with the Takahashi, we guide with the plane wave because we only have the guide scope on the plane wave. So right now the 20-inch scope is one very big guide scope, which is crazy. So yeah, currently I'm using just the acquire single image window here. We do have another one. Called the color series window here. So here's of course where you can do images through many filters. So you don't have to keep entering stuff in the single image window over and over again. You can do as many images as you want, at least before the sun rises. And you can select all your filters here and do a series of images through various filters at various exposures. So we do have that, but during the online sessions, we just make do with the single image one, just because we can just do one picture at a time. And of course, there's all kinds of other features here in the ACP web interface. We do, of course, you can do calibration frames like dark and bias. You can do flats, which I just got done setting up. And there's other local features. There's local weather. You can see the weather here. Of course, it gives the wind speed in knots, which is never terribly helpful, at least not to me. And of course, we can put in the clear sky chart for Arizona Sky Village. And we do have a radar animation. Hopefully there's nothing to worry about there, just noise, so that's good. No big green blobs heading toward Portal, which is actually right about here, by the way. So the observatory is somewhere down there somewhere. And we're almost done there, so we'll wait with bated breath. All right. Hopefully you heard that little ding there. So the image will download. It'll get processed real quick. It'll make a thumbnail and a kind of reduced version and upload it to the browser. Looks pretty good.
Yeah.
One bonk. I learned my lesson last year. Don't do anything till you hear the other bonk. There we go. Okay, and the window pops up. So here we go. All right, looks a little bit better quality than the last one. There we go.
Ooh.
Wow.
Very nice. That is a hoo-ah for sure.
All right, so that one definitely paid off. So the California Nebula, does exist in the Orion arm of the Milky Way, the same arm that we are located within. So it's kind of a neighboring cloud of dust and gas. It is probably illuminated by Xi Persei, the star about a degree away that I mentioned earlier. Xi Persei is actually a hot blue-white giant star of spectral type 07.53. So the 3 does denote that it is a giant star. So it'll probably get larger and larger as time goes by. And the Perseus OB Association, the Perseus OB2 Association, of which Xi is a member, probably arose from this interstellar cloud. So this is basically what's left after forming the Perseus OB Association. So, you know, many nebulae form star clusters or open clusters, which are bound by gravity, but associations also form a nebulae, but they are not bound by gravity. And you can see why the hydrogen alpha filter is so awesome, because it just shows you these billowing clouds in the California Nebula here. So again, I have no idea which way north is. I'd have to kind of take the time to think about it. But that's one project you can do yourself later, because don't forget, you'll have access to these images, and you can download them and figure out which way north is. So there we go, the California Nebula.
That's beautiful.
Richard, how long do these images stay on the link that you send us?
Oh, that's a good question. As some of you might know, I'm very conservative when it comes to space on the website. So if it's old, I tend to get rid of it. But I'll probably keep the zip files that contain the images up until maybe April or May. So odds are, if it was like last month, last month, I had the images available for download by Sunday afternoon, pretty early Sunday afternoon. So if they're not available by Sunday evening, just drop me a little note. Hey, are the images ready? But just keep providing that link that I gave members and those on the online viewing session email list. Check that. Just keep checking that, or I'll give you the link later tonight if you don't have it already. So yeah, I don't keep them up there forever. But if you download them in the next month or two, it will not be a problem. Probably even the next 4 months or so. So they will be up there for a while. So for example, the ones from last year, they're not on there anymore. And unlike last year, this year, I am making the full resolution versions available, but they will be JPEGs, or did I make them TIFFs last month? I can't remember. I'll check on that. All right, so we'll come back to the browser here later, and you'll get to check that image out yourself. So that is 3 targets with the Takahashi. So now I'm going to scroll down here, and I'm going to hit the old script here to switch from the Takahashi to the plane wave. So we're going to switch to the big scope now. So this does take a bit of time. So while we're waiting, let me hop back to the old PowerPoint here, and I'll set you up on the Takahashi. Or I mean the plane wave, obviously. So we are now switching to our main telescope, the plane wave Cdk telescope. So this is, of course, a 20-inch corrected dull Kirkham telescope. So that's what CDK means. So it's a 20-inch corrected dull Kirkham telescope. So that's why they call it the CDK 20. Amazing the way those things work out. And yeah, so our main instrument here does weigh about 140 pounds, which is absolutely no problem for our mount here that I'll talk about shortly. So again, I'm not going to bother to go through all this. I'm going to keep the slide up here for just a second, and I'm going to just check to see how the switchover is doing. But usually it's pretty self-sufficient. In good news, the wind is now down to about 7 miles per hour. working away there. So here's the imaging train for the plane wave. So of course we use the same camera on the plane wave that we do for the Takahashi. I mentioned that earlier. The same filter wheel with the exact same set of filters in the exact same order. To focus, we use digital focuser, which when it does focus, it is very noisy. The focus should be pretty, I got unmuted there for, I got muted by the co-host. How rude. Okay, so I think I'm back on. So the focuser here is pretty loud, but it should be reasonably focused from last night because we certainly don't have time for that. And instead of an off-axis guider, we use an on-axis guider, which allows us to select guide stars in the field that the main camera here is looking at. There are many advantages to that, which I won't bother to go into. And we do use a quite popular Lodestar X2 auto guider. So of course the light comes into here, only infrared light goes into the guide camera. Then most of the visible light, like 97% of it, goes into the imaging camera here. And of course the workhorse is our software BISC Paramount ME2 German equatorial mount. So this is a very fine robotic telescope mount. It does have a capacity of 240 pounds, and we are probably not even at 200. And where did that come from? Uh-oh, we have a hacker, it looks like. How did that happen? That's interesting. So we're going to have to find out who that was and have him drawn and quartered. So that's something new. Some total whack job has joined us tonight. Thank you very much. So there's our mount. Beautiful shade of red. All right, let's see how we're doing here. Okay. So we've switched telescopes. That's good. Oh boy. Very nice. Maybe that's one way to get rid of that. You're a sad person, whoever that is. Okay. So our next target is going to be M74 the Phantom Galaxy, but I got to hop back to the browser to start the image there. Okay. M74. And we're going to jump down to 5 minutes for this one. And we'll hit acquire images there. Okay. We'll get rid of that real quick. Yep. So we're learning all about this Zoom stuff all the time. And we learned you can do some pretty unfortunate stuff. So let's switch back here. We'll see how we can do here. So our next target is M74 the Phantom Galaxy. That is a name given by the famous observer Stephen James O'Meara, who was a one-time contributor to Sky and Telescope. Hasn't been with them for quite some time, but he's also a prolific author. And I do own many books from him, which is why I include that in here. This was discovered by Pierre Méchain, who was Messier's assistant in late September 1780. Méchain actually found about 24 or 25 objects in the Messier catalog, which includes NGC 5195, which is one of the companions of the Whirlpool Galaxy, or the companion of the Whirlpool Galaxy. So it does have a fairly low surface brightness, which makes it one of the more difficult Messier objects to observe. And it is located about 1.5 degrees east-northeast of a star called Eta Piscium, which I'll show you here shortly. All right. So here is roughly where M74 is located. So it is in the constellation Pisces, which it's easier to find Pisces with the circlet here. This asterism below the Great Square is called the circlet. And you can just kind of follow these stars under pretty dark skies and then hop up here. Oh, did I forget to switch the filter? I do believe I did. Let me hop back on that. Oops. Okay. Yep. So I'm glad Kevin caught that there. And I did forget to do something else as well. Give me just a second here. I lost my connection to the remote computer there. One thing I have to do is I got to switch focal lengths. And so I got obviously a little distracted here, and I forgot to do that. So bear with me here. We're getting a little distracted because you just can't have good things, right? All right, we're switched off there. And we're going to try this again. So give me just a second here. Okay, I'm caught back up here. I am sorry about this. We got thrown off by a weirdo. He obviously meant to cause problems, and he is succeeding. Let's see how we're doing here. Oops. Is that where I was? There we go. So we should be back on the browser now. We'll see how we're doing there. So we are slewing. You can see it's not going to slew very far. It's currently doing the fine pointing, we call pinpoint. There's a little program on here called pinpoint that perfectly centers the object for us, so long as I have the right focal length entered into ACP, because you could really only use one telescope at a time with ACP. You have to manually switch the focal length. Hopefully they'll change that in a future version. And pretty quickly here, it'll start guiding, it looks like. So you can see the guide star that is selected. Unfortunately, this doesn't update, and it'll start guiding as soon as it gets the proper guide settings. So you can see it's going through various guiding scenarios here, and eventually it'll pick a good one, and it'll hopefully start guiding, I hope. I haven't had issues with that yet. Oh, there we go. It found something. Let me hop back here, see how we're doing. Mike has his porch light on now, so you can see his house illuminated. You can see Orion's gotten a bit higher. And we're doing good there. All right. So we have M74 here. So again, this is very close to the star Eta Piscium here. So again, M74 is another easy star hop with a telescope, or of course everyone today just hits M74 on their keypad to go to it. But if you do want to star hop to this with a good old-fashioned Dobsonian, it's fairly easy to do from this moderately bright star there. So, of course, one thing some of you can do, I'll look into this myself, is a little extra security for Zoom sessions to see how we can prevent people from interfering like that. So we're just learning with the Zoom stuff all the time. So let me scroll back through the chat here and see if I can find some questions or anything to answer. So someone's asking about using a Nikon D3500 until we get a standard astro camera. I've been using a DSLR myself, mainly Canons, for years, and so I would definitely start out with a DSLR before venturing on to anything else. You know, start with tripod photography. Do wide field shots of the constellations, maybe Aurora if you're lucky. Do some scenic shots of the Jupiter-Saturn conjunction with a nice foreground, like a lake or something like that. That's how I usually make like space weather, or you know, or astronomy picture of the day. Is they go for images with cool foregrounds. So so that's a good thing to work on with tripod photography. And of course, someone always asks how much everything costs. When it comes to this, I tend not to answer that question too much. But I'll just give you a broad version. Is we did an 8-year fundraiser for this, 60% of which was funded by members, and we raised about $122,000 in total. We did not spend all of that, so that kind of gives you a ballpark of it. I typically don't have time for requests, but if we do have a little extra time, if anyone wants to hang out later, we can do a few requests after my appointed objects here, because I have tried requests in the past, and often I just get silence. So often I just plan out 6 images, you know, 3 for each telescope, and go from there. But I'm happy to stay around a little past our usual time, and we might go past that a bit tonight because of our hacking issue here, and we can maybe try a few other things. But one thing I do want to avoid is doing objects that I'm going to do maybe next month or in February. So if there is one object that you might want to see that we're going to do next month, I'll just encourage you to come back next month. All right, so let's switch back to the web browser, if we dare. And we can see the all-sky image there. Very carefully pop up the browser. Sometimes the zoom stuff at the top here gets in the way of the tabs of the browser. And we're still guiding away, but this time we're only doing 5 minutes or so. The guiding looks better. You can see it's not quite as choppy. So the current wind speed is now about 7.3 miles per hour, a little windier than I had expected. The guider, the guide star looks nice and normal, so that's good. And so, yeah, this is the great thing about ACP with Maxim, is it'll try many different guiding scenarios to find the best one for you, and off it goes. All right. Suspense is always wonderful. Uh-oh, looks like we had another type of photobomb. If it's not one type of photobomb, it's another. All right. Gotta wait for that pop-up window. There we go. Okay, now it should be done. So we did have a satellite drift through. I don't believe in all the images. We did 6 images last month and not one satellite. Well, we got one tonight. Maybe even, looks like maybe another one. Really faint, something there. So there we go. Isn't that beautiful? So there is M74 the Phantom Galaxy. And this is basically a textbook example of a grand design spiral galaxy. By that, we mean it has 2 very nice symmetrical spiral arms. Not too many branches or spurs, branches or spur arms like our Milky Way has. So you can see one very nice arm here, one very nice arm there, maybe just a slight bit of spurs that branch off into other segments there. So it's a very nice grand design galaxy. It's about 95,000 light years in diameter and contains at least 100 billion stars. M74 here is the gravitational center of a small galaxy group that includes many other galaxies. There's NGC 660, UGC 891, 1176, 1195, 1200, and one called UGCA 20, and 2 others, UGC 1171 and 1104, may also be members. So I just kind of mentioned that for fun. And one really neat thing is there have been 3 supernova in fairly recent history in M74, at least 2 possible in 2002, but one of the 2002 ones was a hypernova, so not really a supernova. One more in 2003 and another one in 2013. So that's 3 supernova and 1 hypernova in the past 18 years. And remember, on average, you get 1 supernova in a galaxy per century. So there's a lot going on here in M74. And the Chandra X-ray Observatory may have found an intermediate mass black hole in the center of this galaxy at just 10,000 solar masses. So that's really unusual for a galaxy of this size to be this big, but have kind of a low mass black hole at its center. So just a gorgeous face-on galaxy. So there we go. So next target, well, very important to have that space in there, is M33. Okay. Make sure I check the right filter. Yep, we're good there. We're going to do another 5 minutes and off we go. Okay, we started. Because last month I didn't hit the button quite right and I wandered off and it just sat there and did a whole lot of nothing. So I want to make sure it goes off properly that time. Okay, so here's our next target, M33 the Triangulum Galaxy. Some people I have heard myself refer to this as the Pinwheel Galaxy. But that name is often reserved for M101 in Ursa Major. So since this galaxy is the major galaxy in Triangulum, why not call it the Triangulum Galaxy? Makes sense to me. This was probably discovered by the Italian astronomer Giovanni Battista Hodierna before the year 1654. And he noted it as a cloud-like feature near the triangle. Very descriptive. It was independently discovered by Charles Messier on the night of August 25th, 1764, and he duly made it the 33rd entry in his objects that look like comets that are not comets catalog. And this was among the first spiral nebulae identified as such by Lord Rosse using the Leviathan of Parsonstown, a grand 70-inch telescope in Ireland in 1850. So obviously, most of those spiral nebulae turned out to be spiral galaxies, but they didn't know that at the time. So this is basically on the opposite side of Andromeda, as opposed to the Andromeda Galaxy. And so here's its rough position in Triangulum. I know it looks like it's closer to Pisces, but there are like constellation borders out there, and so technically this is across the border in Triangulum there. So that's why we call it the Triangulum Galaxy. And zooming in close up there, we can see where the Andromeda Galaxy is with comparison to M33 over here. So it's about 4 degrees west-northwest of Alpha Trianguli right there, which is about 3.4 magnitude. And again, M33 and M31 lie on opposite sides of a nearly equal, let me try that again. They're on opposite sides of a nearly equal diameter distance from Beta Andromedae right here. So yeah, they're about the same distance either way from Beta here. Merope. Let's see how we're doing. Doing well there. So it's guiding away. The guiding looks a little bit better now. It's still about 7 miles per hour out. Let's hop back to here, see how we're doing. And I can give you a sense of maybe where the telescope is pointed right now. We know where it's pointed at. And that looks pretty accurate. Let me hit reload just to be sure. Because it's going to be obviously pretty high right now. I can even show you where we're imaging on the all-sky chart here in just a short second. And just out of curiosity, Kevin, is the person in the waiting room the troublemaker? I don't know if you found out who it could have been, but there was someone waiting there in the waiting room for quite a while. But if it's the troublemaker, we'll ban him for life. So yeah, so we're looking pretty high this time. You can see the flat field box a lot easier. Not terribly exciting, I know. So here again is the Great Square. And here is Beta Andromedae. And so M33 is like right about there. Boy, if with all the little bits of noise around here, I cannot make out Triangulum. I think this is Aries. And Triangulum's up here. Oh, here it is. There's a 2 stars right there. 2 stars very close together and 1 star down there. So there's Triangulum, and so that gives you a sense of where M33 is. There we go. I was going to switch tabs here, but okay, we're almost done there. So we do have other features. One handy feature is the dawn-dusk times. So you can see when true darkness falls. And so it looks like it was at 6:37 Mountain Standard Time. That's always a handy feature in case our users are curious when it's truly dark. About 40 seconds left. I think we'll just go ahead and keep it here. We're getting there. So this is our kind of second season of doing sessions like this with the KAS Remote Telescope, but this is actually the first season of online sessions. Last year we did them in person at Western Michigan University, the big university in Kalamazoo here, and it was a modest success. The attendance was pretty good, maybe between 30 to 50 people, and but I felt doing online sessions was a way to reach a larger audience. And we certainly have done that. We do have people from all over, and many of you have stuck with us. So we do appreciate that. And but of course, there are, as we've seen tonight, there are drawbacks to doing online sessions as well. But there are ways we can find to stop that. All right, it looks like we're done there. We'll wait for the actual image to upload. Takes a little bit longer than the thumbnail here. There we go. All right. So as you can see, it's big. It fills up quite a bit of the chip, even though it is a full frame camera. So there we go. Isn't that gorgeous? I'm sure we have everyone muted for safety reasons, but so far, so good. Things look okay. So it is inclined by about 54 degrees here, providing us with pretty moderate face-on view, not perfectly face-on, but pretty close to face-on. And this, of course, is the third major spiral galaxy in the local group. Of course, there's the Andromeda Galaxy, the Milky Way, and the Triangulum Galaxy. There is a fourth spiral galaxy in the local group. And so for kind of a fun thing, if you know what the fourth spiral galaxy is, enter it into the chat and I'll see who's right. So this is quite a bit smaller than both the Milky Way and the Andromeda Galaxy. Along at least the long axis here, it's about 60,000 light years in diameter and contains about 40 billion stars, which is about 60% the size of the Milky Way. It is currently moving toward M31, so this does suggest that it is a satellite galaxy to the Andromeda Galaxy, but I do not believe that is known for sure. So M31 and M33 are less than 300 kiloparsecs, 300,000 parsecs, probably about 1 million light years distant from each other. And many do say they will merge in about 2.5 billion years. But as we saw in that video of the Andromeda Milky Way merger earlier, that did not show it. So maybe M33 will survive, but the Milky Way and Andromeda will become one. And this is another galaxy, strangely enough, that does not appear to contain a supermassive black hole. And in the lower left here, right about here, we have NGC 604, which is one of the largest known emission nebulae, period. It's about 1,500 light years in diameter. So if we do image this in H alpha, which we're not going to do, this really, really shows up while most of the disk here disappears. So it is a beautiful galaxy. It is hard to observe though, but it is a bit more distant than the Andromeda Galaxy. And from a very dark site, you can see it with the unaided eye. So this is perhaps the most distant object you can see with the unaided eye. That's probably not quite true either, but it's definitely doable from a very dark site, like Arizona Sky Village. But I personally have only seen it naked eye somewhere between Flagstaff, Arizona, and the Grand Canyon at a friend's former bed and breakfast. Some of the darkest skies I ever encountered. So there we go, M33 the Triangulum Galaxy, beautiful. All right, so our last target for the night is NGC 1435. Now I'm going to get coordinates there just to get it roughly laid in, but I want to frame this a very specific way, so I'm going to modify this just a little bit. because sometimes I'm picky how it frames these. So we're not limited to how the program frames it. We can modify that. There's another way to do it besides this, but I have this planned in advance. So we're going to stick with the luminance filter. 5 minutes makes it look quite spectacular, and off we go. Make sure I hit it. Yep, I hit it that time. Always got to check that. So let me switch back here. So you might be thinking, I'm not quite sure which object is NGC 1435, but trust me, you know which one this is. So NGC 1435 is the Merope Nebula. If you're still not sure, you'll see soon. Now, I did see some estimates online, like Wikipedia, never a 100% reliable source, that gave us a magnitude of 13. I'm like, no, that's not right at all. So the magnitude here is probably more for the star Merope itself, but the nebula is probably a bit fainter than that. But if you do use averted vision, you can even see this with the unaided eye. So it's a pretty good sized nebula, about the size of the full moon, and it's about 440 light years away, so not terribly far away. And so you know this object because Merope is one of the stars of the Pleiades. So that's why we're targeting one specific star in the Pleiades. With the plane wave, we can't see the entire Pleiades, but we can just see a section of it. Next month, we'll do the entire Pleiades with the Takahashi, because that's much more suited for that. And so, of course, here it is. And so, of course, the Merope Nebula is a reflection nebula in the Pleiades star cluster. Basically, a reflection nebula surrounds the entire Pleiades, but this is the brightest part. It is also known as Tempel's Nebula because it was discovered by the German astronomer Wilhelm Tempel on October 19th, 1859, using the 4-inch refractor. Now, naturally, the Merope Nebula is illuminated by, you guessed it, Merope. And it does contain a bright knot cataloged as IC 349. And as you can see here, it's practically, not physically, but it looks like it's inside Merope. But because it's so close, it is very, very difficult to spot. And it's only like half an arc minute away from Merope. And IC 349 was discovered by E.E. Barnard in November 1980 using the famed 36-inch Lick refractor in California. And so IC 349 here is 15 times brighter than the Merope Nebula itself. But it is, of course, hard to spot thanks to Merope. We probably will not see it in the image tonight because I'm doing a longer exposure to pick up the Merope Nebula here in all its glory. So we'll, of course, look at stuff like this again next month when we do the Pleiades itself with the Takahashi. It is a great target for the Takahashi, the spectacular image to boot there. Oops, so let's hop back, see how we're doing there. Just check in with ACP. We already have a guide star and we are off and running. It obviously should not be very hard to get a guide star in the Pleiades. There's lots of bright stars there, but we don't need one too bright. So we are guiding there. And let's break away here. Oh, good. People are doing ooh, ah in the chat. That's better than nothing, right? So let me back up here a bit. So I'm sorry, apologies to Dick and Jackie for continuously getting shut out. I don't think that's on our end. It must be maybe an internet issue on your end or something. I don't know, but sorry to hear about that. Yep, that is Orion rising in the east. We'll check back on Orion here later. And I'm glad Some people said they'll be regulars. Somebody asked, why is M74 called the Phantom Galaxy? I would have to break out my Stephen James O'Meara book behind me there. It's one of these books here, and I'd have to tell you specifically, but he just found it, he just found that name fit for it. So that comes from Stephen James O'Meara's Messier Object book, which I think you can get from Sky and Telescope's website. And someone asked, are we going to colorize these images? Not for the downloads that you'll do later. Of course, we have to do a whole series of images, and eventually I'll show you, we might show you a color image here shortly. Okay, so I did not see, it does not, one thing I was looking for here is, did anyone answer my question of what is the fourth spiral galaxy in the local group? So it doesn't look like anyone knows. So, gosh, I feel so superior for some reason. No, most people consider this galaxy a irregular galaxy, but if you go online and look for pictures of it, the large Magellanic Cloud is very much a barred spiral galaxy, just kind of a mangled one by the Milky Way. So yeah, the LMC is considered a spiral galaxy by most catalogs now. But it is kind of an odd looking one because it has been ripped apart a bit by the Milky Way. So yeah, the large Magellanic Cloud is kind of a barred spiral galaxy, just like the Milky Way, just smaller. All right, see how we're doing here? Almost done. So we'll stick with this here. We'll pop this up again for a second. Check that out. So there's M33 again. Pretty good one. I would like to do 10 minutes of this, but yeah, we can't do too many 10-minute shots. They do take some time. And so checking in, yep, there's Orion. It's getting quite a bit higher now. So now you can see the belt stars much easier. You can see the two stars in the feet, Rigel and Saiph over here, S-A-I-P-H. You can see the sword of Orion. So the Orion Nebula is like right there. But we'll look at that next month. And we're almost done. All right. Now, early on, at the start of the night, you probably briefly saw the thumbnail image already because I checked my framing on that last night after our meeting. And there we go. So there's the thumbnail. Looks very familiar, hopefully from earlier. And we got to wait for the main image to upload. There we go. So there we go. Isn't that beautiful? So I like to frame it like that. If I let ACP frame it, this star here is out of the field of view. I'll mention that one here shortly. So so right toward the center here, just below the main center, is Merope itself. So in Greek mythology, Merope is one of the 7 daughters of Atlas and Pleione, I believe, known as the Pleiades. And Merope, in actuality, is a blue-white B-type supergiant. So it is a star no longer on the main sequence, but it's not quite a giant or a supergiant yet. It'll probably become a giant star and eventually form a beautiful planetary nebulae, much like the Ring Nebula, for example. So it's a B-type star, hotter than the sun. It has a surface temperature of about 14,000 Kelvin compared to the sun's 5,800 Kelvin. Because it is a subgiant and quite a bit hotter, it is 630 times the sun's luminosity. So it is quite a bit brighter than the sun. It's 4.5 times the sun's mass and about 4 times the radius as the sun. So it is large. And so, of course, surrounding the Merope, kind of little off axis a bit, is the Merope Nebula itself. And all reflection nebulae like this one, and I'll show you an example here, do have a blue color because the dust particles in this nebula are very tiny, and they are able to scatter blue light, which has a short wavelength. But the longer wavelength red just passes on through the cloud. So blue light can be scattered by the tiny dust particles, and so that's why reflection nebulae here are blue. Now, we used to think the dust and gas around the Pleiades and Merope were leftover material from the cluster's formation, but we now know that the Pleiades are just plowing their way through a dusty region in the Milky Way. If you do get online and do like, I don't know, like deep field Pleiades or deep field Pleiades image or something like that, you can find very long exposures of the Pleiades where you can literally see it plow through the gas and dust in the region. So we do now know the gas and dust here has nothing to do with the cluster itself. It's just they're passing through a dusty region and reflecting starlight off the dust. Now, the star here to the lower left in this image is Alcyone, which is the brightest of the Pleiades stars. And that's why I like to frame it like this. And kind of going from Alcyone here, you can see that chain of stars, this line of stars in the Pleiades. Now, I sort of egotistically call this the Bell string, because remember, my name is Richard Bell. So I'm trying to have this catch on, people. So anytime you show people the Pleiades through your binoculars or telescopes or in a picture, refer to this string of stars as the Bell string, okay? Just do me a favor. You know, admission was free, so consider this consider this your admission to call that the Bell string from here on out. Now, when I do give this image to you to download later, I'm going to flip it over because the telescope is in the current orientation to where we see it sort of, as I would call it, upside down. So I might come back to this in just a second, but let me switch back to the PowerPoint here, because one thing I don't do here is I don't show color images, because you know all our images are monochrome and we can't really compete with those because it takes time to take enough images to process these to get color, but I do make exceptions when they come from our telescopes. So this image is one I took early last year of the Merope Nebula. So this was taken with 12 luminance filters with the same exposure we just did, 5 minutes. So it's 12 5-minute exposures and 6 5-minute exposures each through red, green, and blue filters that I stacked together to create this color image here. So here's Merope. Of course, here's Alcyone, and there's the Bell string. There it is right there. So yes, this is from our telescope. So this is the time I make an exception to show a pretty color image. And it's a little over 2 hours worth of imaging. So there you go. There's one color image from our telescope of this object here. So you can kind of compare this one with the one we just took, you know, in quote, real time. So there we go. I just love taking this wasn't like the perfect position early last year. So that's why I chose this for our first color image, because that is also the very first color image to come from the telescope. All right. So real quick here, let me switch back to the PowerPoint and just mention that, of course, if you live in the Southwest Michigan area in one of the counties in red here, you can join the Kalamazoo Astronomical Society and use the remote telescope yourself. There is an extra fee in addition to a full-blown membership, a full membership, but it's a bargain compared to the commercially available remote telescopes like this one. It's you can do a regular membership for roughly $21 and pay $50 a year to use the telescope. You know, $50 is one night, not even one full night on a commercial telescope. But for 50 bucks, you can use the telescope 9 out of 12 months of the year, because remember, we shut it down for 3 months in the summer. And so I hope you all do join us next month. Our primary date for the next online viewing session is January 9th, with a cloud date of January 16th. So obviously, we're not going to be online here next Saturday, December 12th, because we were successful tonight. And we do have sessions on February 6th or the 13th as well. You can register for these 2 sessions right now on our website. Or you can also join our online viewing session email list, and I can email you a reminder. Just go to the contact form on our website, and there is an option to say that you want to join the online viewing session email list. And I will send you at least 1 email a month to tell you a session is coming up in case you forget in your hectic schedule. And another plug here is everyone is welcome to join us for our next general meeting. Our next meeting will be on January 8th on Zoom. And we do have a special guest speaker, Dr. James Ashley from the Jet Propulsion Laboratory. We'll talk about the InSight mission on Mars. And again, you can register for that on our website right now. I'm doing a 12-week course in astronomy starting on January 12th online. You can contact me either through the website or through my email address, which I could give you later. But if you go to the KAS website, you can see a slide like this one to download the syllabus. It's right from the main page of our website, so you can check that out. Again, it meets twice a week for 12 weeks. Just the bad news is there is a fee. So, because obviously it's a lot of work. We do have a free lecture series coming up though. Our Introduction to Amateur Astronomy lecture series starts on January 23rd and then meets every 2 weeks, once a week, every 2 weeks. And we currently have roughly 80, 81, 82 people registered, and I will have to cut it off at 100. This will be a closed session, so we should not have any issues with hackers or anything unless someone registers through our website and causes problems. But you can't register through Zoom. You have to register through our website. And so here is the link to download tonight's images. I will keep this up here for a second or so. If you are a KAS member, you have this email or this address in the email I sent out on Thursday. If you're on the online viewing session email list, you have that email there as well, or you have this address here as well. But if you're just joining us tonight, you found out through PhilPlate today and joined us tonight, you can do a screenshot, take a picture of the screen with your phone, or if you can write it down really fast, just write it down. And I will have all the images we took tonight available at this link right here. So I can bring this back up shortly, or maybe if somebody is so kind, they can pop it into the chat and you can copy and paste it from there. And remember, I probably won't have these available until Sunday afternoon. I'll kind of give myself a deadline of like 3 p.m. or so. I'll try to have them online by 3 p.m. Sunday tomorrow.